Hello everybody. So today we'll be continuing our Form 4 Chapter 7 Chemistry lah. So these questions we're gonna play fun a little bit lah. Okay. So Dr. Chong says what? Dr. Chong says you can eat this antacid tablet, antacid tablet to relieve your stomach ache. This tablet, pardon, can can be swallowed directly or chewed. And then the patient said, yes, Dr. Chung, like that. Okay, so what happened here is that you have to know that antacid tablet is actually a basic. It's not acidic, but it's basic, which means it's alkaline. What it does is it helps you to reduce the acid in your stomach. Because when we are having stomach ache, right, what happened is that the hydrochloric acid in our stomach is actually hurting our stomach walls. So because it's too acidic at a state that it starts to hurt your stomach's wall. Okay. So this antacid tablet is alkaline, which helps you to neutralize with the acid in your stomach, which reduce your pain and reduce the hydrochloric acid in your stomach, the acid in your stomach. Lah. So this tablet can be swallowed directly or chewed. Okay. So let's go down and see what the question says. Okay, first question says, based on diagram 9.1, which method will relieve the stomach pain faster? Come on, the keyword here says faster. Then explain your answer. So there's 3 marks here, as you can see, 3 marks here. That means they are expecting us to write 3 things out. Okay, so the first marks we're gonna say what? The first marks we're gonna say, oh, so by chewing the tablet, it will be something like this. You have to get the direction of how to write your answer. There is a technique. It's not just about memorizing, but about understanding. So the first thing I gotta know is A. Look back to the question. It says it can be swallowed directly or chewed. Let me ask you one thing. If you chewed it, would it help to relieve the stomach pain faster? Come to think about it, the moment when you chew it, right? What happened is that chewing helps to break the antacid tablet into smaller pieces, which what? Which increase the total what? There's something there, total surface area that is exposed to what? Exposed to the acid in your stomach. So the first mark, you're gonna say, how? They're asking you, right? How? Which method, right? You're gonna say, I'm going to chew the tablet. Okay. Wait. I'm gonna chew the antacid. I'm gonna chew the antacid tablet instead of just directly swallow it. Okay. Chew the antacid tablet. So chewing, the next mark says what? The next mark says chewing helps what? Chewing the antacid tablet. Chewing the antacid tablet helps to break, the keyword here, helps to break the tablet, the antacid tablet helps to break the tablet into what? Into smaller pieces. Then you try to relate it more. So what you're gonna say is that I chew the antacid tablet. The moment when I chew, right, I break the tablet into smaller pieces. The moment when I break the tablet into smaller pieces, what happened? What's the relationship between the tablet and my stomach? Is that my tablet becomes smaller, which means the keyword continues here, which means that A, this helps to increase the total surface area. The moment right now I have to change. This helps to, which relates that here. This helps to increase the total. Hey, please write total. Because the moment if you didn't write total, the moment you mistake it, you didn't write it, 0 marks. The total surface area, to increase total surface area of tablet exposed to acid. Done. Here is your 3 marks. So again, please, the moment you know surface area, you know that smaller pieces relate to surface area, but don't forget to put your total, because during my time, I used to forget to put total and then I didn't get any marks. That's my scenario at least. So here's your 3 marks done. So we go to the next question very fast. Write a balanced chemical equation to represent the reaction between antacid tablet and hydrochloric acid. And then okay, one by one, okay? So here write the balanced chemical equation, represent reaction between your antacid tablet and also your hydrochloric acid. Hey, wait, sorry. I think I'm mistaken something here. Did I? Where is my table? Where is my table? Oh my God, my table. Sorry, I mistaken one question. Okay, here. So the question continues. The antacid tablet contain calcium carbonate, like keyword here, calcium carbonate. Calcium carbonate means what? It's CaCO3. Okay, the chemical is CaCO3. So how do you know CaCO3? Okay, basic Ca2 plus CO3 is 2 minus. Okay, the moment you bring it down, the moment you bring plus minus, take away. Okay, minus, take away, 2 again, take down. That's what you get, CaCO3. Okay, no problem. And then now the table shows that, okay, the first keyword says antacid tablet contains of CaCO3. And then the table 9 shows the volume of gas collected against time for the reaction between your antacid and your hydrochloric acid. Set 1 and set 2 use different size. Set 1 and set 2 use different size of your antacid tablet. Okay, now go down. We'll notice that the volume collected is different, of course, and the time taken is also different. In this case, for the set 1, right? For set 1, it's here. And set 2 is here. You realize that a constant gas volume of gas is obtained. So the moment you realize this, right? Okay, I'm gonna bracket it. That's what I'm gonna do. Meaning, for your first set, right? For your first set, at your second minute, time is in terms of minute. Sorry, I forgot to write. Times is in terms of minute. Second minute. Alamak. Second minute. It already obtained a constant volume, which is your 48.00 cm cube. For set 2 means 72 is obtained on the 4th minute. That means like 72 cm cube, like that. Okay, this is what the graph is trying to tell you, the table is trying to tell you, sorry. So now the question asks, calculate the average rate of reaction. Come on, this one just hantam formula only. Average rate of reaction, okay, for your what? For your set 1 and your set 2. Okay, for your set 1 and your set 2. And stated there 2 marks. Okay, so without further ado, do you remember the formula? So I'm going to write down formula here. The formula is average. Your average rate of reaction formula is total volume divided by your total time. Okay, so so going back down here, okay, we're gonna put this thing here and then we start to do both, and then we're gonna it's like substitution, simple as that. So here, we're gonna do set 1 first. Okay, so set 1. So set 1, let's average. I'm gonna say average rate. Average. I'm gonna write short form rate of reaction. It's gonna be total volume divided by your what? Total time, right? Yes. So total volume divided by total time. So let's look at set 1. Your total volume is here, right? 48 cm cube. Then your total time taken, how much? 2 minutes. So just divide them. Simple as that. So I'm not gonna waste so much time here. So I'm just gonna sub in the answer and that's all. So 48 as your volume and 2 minutes. So what you are gonna get is your 24 cm cube per minute. Okay, please don't tell me that you don't know why is it per minute here. The reason being is here, 48 is your cm cube, right? The volume of your carbon dioxide gas collected. And the 2 here is your minute. Agree or not, it's just up there. Look, time is in terms of minute, give you already. Volume is in terms of cm cube. The moment you put it down, please write it down, cm cube. Cm cube per minute. That means your minute, you bring it up, become -1. This is basic. Okay, set 2. Okay, I'm gonna change color, okay? Set 2. Set 2, okay? Average rate of reaction. Okay, again, we're gonna look up according based on the table. Don't by sendiri like that. Pandai sendiri. 72, right? Okay, letak 72. 72 total volume divided by how much? Your time taken is 4 minutes, right? 4 minutes. 4 minutes. Okay, so put 4. Then what you get? You will be getting your 18 cm cube per minute. Done. Okay. So this is our 2 marks. We get our 2 marks on hand already. Next, we go to the last question. Okay, so what does the last question say? Write a balance. Sorry, something wrong. Write a balanced chemical reaction, a chemical equation to represent the reaction between antacid tablet and hydrochloric acid, and calculate, okay, the mass of your calcium carbonate. Again, slowly read. Write a balanced chemical equation represents the reaction between your what? Between your antacid tablet and your hydrochloric acid. I want balance punya chemical equation. Balance punya chemical equation. Okay, here is your first thing you gonna do. Second thing you gonna do is calculate, okay, continue, and calculate the mass of calcium carbonate in the antacid tablet in set 2. Okay, this is the second thing you're gonna do, and please set 2. It already says that set 2 means you do set 2. You don't do set 1. No such thing, okay? If you want to get 0 marks, go ahead lah. Write a balanced chemical. First thing we have to do is write balanced chemical equation. Okay, so balanced chemical equation here, we can see that A, antacid tablet, do we know the chemical? We know. Why? It says here, it already tells you that A, antacid tablet contains of calcium carbonate, which means it basically is calcium carbonate. So, and what's in our stomach? In our stomach is hydrochloric acid, right? So, do we know what's reacting with what right now? We know the reactant, right? So, what is it? It's your antacid tablet calcium carbonate together with your HCl hydrochloric acid, which in your stomach. What you're gonna get? Okay, this is some technique here I'm gonna teach. Okay, the moment when I see got O, got H, I'm gonna write down H2O. I'm gonna write down H2O. Next, the moment when I see C and O, C with C and O together, C, the moment, just the moment when I see C, the moment when I see O, I put CO2. And lastly, nevertheless, okay, Ca and your Cl, put it together. What you are gonna get? Some basic Ca is your 2 plus calcium, Cl minus 1 minus. Okay, what happened here is that A plus minus gone. Your 2, bring it down. Then you're gonna get what? You're gonna get CaCl2. So write it down. CaCl2. Done. I'm gonna write this off. Okay. Remember. They said balance. So what you are gonna do right now is going to balance it. So let's take a look here. We have Cl2 right over here. We have Cl2. Okay, Cl2. Do I have Cl2 here? No, I don't. So what I'm gonna do is I'm gonna put 2. Okay, now I have 2 Cl2 Cl2, and then do I have 2H here, 2H here? Nice balance. Okay, then oxygen, look by itself. Oxygen by itself, don't mix. So oxygen here 2, and add 1 here is 3 oxygen here. 1, 2, 3, nice. Calcium, how many? Calcium 1, nice balance. Done. Simple as that, right? Nice. Okay, so we balance our chemical equation already. So Yes, we get marks already. Next, what they ask? They ask, calculate. Okay, sorry. Okay, calculate the mass. Calculate the mass of calcium carbonate. Calculate. Usually, the moment when I read the question, right, I saw like calcium carbonate HCl. I will write the chemical formula here first. Okay, calculate the mass of calcium carbonate in the antacid tablet. Okay, simple enough. So what we are gonna do right now is, hang on. So what we are going to do right now is we are going to find the number of moles. Because in order to find the mass, we need number of moles, right? Because you don't have mass, it's not given mass or whatever. You find the number of moles. So short form, in exam, please write number of moles of CO2. I'm going to short form only. Number of moles of CO2. Oh, a number of moles CO2. Number of moles CO2. Yeah, correct. We need to find a number of moles first. You want to find the mass. So number of moles CO2. Okay, here, let's see what is given. Sorry, let's see what's given here. So CO2, right? This is the gas release is carbon dioxide. How do I know this is actually CO2? Why? How do I know? Because it's based on my equation actually. So what does it mean? Here, you see what is produced? The only gas here is your CO2. When CaCO3 reacting with your HCl, you get water, H2O, carbon dioxide, and CaCl2, which is your salt. So through this equation, it tells me what? It tells me that the gas produced, the so-called volume of gas evolved here, the gas is actually your carbon dioxide. Do you understand that? Yes. So meaning, right now I'm finding the number of mole of carbon dioxide. Is it given volume? Volume of gas, the gas carbon dioxide, right? It is given. And what does they want? They want set 2. Am I right? They want set 2. So what I'm going to do right now, I'm going to look at the set 2. Based on set 2, I do it. Okay, so set 2 volume of gas of 72, right? Okay, 72. Hey, wait. Right now, first, let me ask, number of mole you should know. In this case, we have volume, right? So we're going to use volume. Now we're going to use this formula. Number of mole is equal to volume divided by molar volume. Okay, we're going to use this first. Okay, this one you have to remember, no choice. So we're going to use this formula. And in this case, volume is given, right, 72 cm cube. But I'm going to change color. Here, you don't put cm cube. Please, you don't put cm cube. You're going to put dm cube. Which means when you get cm cube, what you are going to do is you divide by 1000 because cm cube to dm cube, you divide them by 1000. So here, go back to the question. I realized that this is in terms of what? Is in terms of cm cube wall. In terms of cm cube wall, right or not? It's in terms of my cm cube. So 72, I'm going to change it to dm cube. What I'm going to do is I'm going to divide by 1000. So okay, here. So 72 divided by 1000. Move 1, 2, 3. So I'm going to get 0 0.072, right? So put it in 0 0.072 divided by your, how much is your molar volume? Molar volume is fixed, 24, okay? 24. So the answer that I'm going to get, is going to be 0 0.003 mole. Okay, I found a number of mole already. Good. Yes, you get your marks. 5 marks, guys. 5 marks question. Then this is the and then next thing I do is I like to put number. The first step, this is the first step I did. Okay, my first step and my second step. Second step. So my second step, after I find number of mole, I base on the equation. What I'm gonna do is based on the equation, I say something. What something that I said? Okay, here. Based on the equation, agree or not, 1 mole of your carbon, here is your, we name this as coefficient. This is usually like for example 2HCl, right? The 2 here we name it as coefficient. So CaCO3 in front here there's nothing, right? So we don't say 0, we say 1. Basically there's an invisible 1 here, but we don't mention that. This is what we call as coefficient. So in this case, agree or not, 1 mole of CaCO3 produces 1 mole of carbon dioxide. Agree or not? 2 mole of HCl produces 1 mole of carbon dioxide. Or terbalik, I say, 1 mole of carbon dioxide is produced by 2 mole of HCl. Or 1 mole of carbon dioxide is produced by 1 mole of CaCO3. Now the question says what? Read again. Calculate the mass of calcium carbonate. Now we are focusing calcium carbonate. Our main focus is calcium carbonate. So of course we focus on calcium carbonate. So agree or not here? 1 mole of calcium carbonate produces 1 mole of carbon dioxide. Yes, write down. So we write carbon dioxide lah, the balik version. 1 mole of carbon dioxide is produced by 1 mole of calcium carbonate. First thing you're going to do. And then you are going to tell the teacher that if 0.003 mole of calcium of carbon dioxide is produced, then how much is your how much is your calcium carbonate? That means, right? Okay, 1 mole of carbon dioxide is produced by 1 mole of calcium carbonate. Then hence or therefore, here put it in because you found out that A is 0.03 mole. So 0.03 mole of CO2 carbon dioxide is produced by 0.003 mole of calcium carbonate. Done. How do I know it's 0.03? Okay, because since it's 1 ma, right? So agree or not, it's going to be the same. If it's 1 here, 1 mole of calcium carbonate here, that means 1 mole of carbon dioxide produced here. It's just like 1 to 1. The ratio is 1 to 1. As simple as that. Okay. So yes, this will be our what we are gonna write. So from here, right, we're gonna do the third step. What's the third step? Through this thing, we realize what? You see, 1 mole of carbon dioxide produced by 1 mole of calcium carbonate, right? So hence 0.03 mole of carbon dioxide is produced by 0.003 mole of your calcium carbonate. Agree or not? Now that my calcium carbonate is 0.003, so I know that so now it tells me that number of mole of calcium carbonate is 0.003, right? It's like self-communication when you're doing this kind of question. So 0.003 mole is your calcium carbonate punya, right? Okay, here. Now, the third step we are going to do is that now we're going to put formula. What formula? Read back the question when you're lost. The question says what? What they want. Second, they want to calculate the mass of calcium carbonate. The mass, they want the mass. So remember number of mole, the formula for mass that is related to mass is actually number of mole is equals to mass divided by molar mass. This one I have to remember one of these. So here we're going to use this formula right now, and we're going to end the question. Here number of mole, of course we are finding number of mole of our calcium carbonate, right? Read back the question, as simple as that. Calcium carbonate. Number of mole calcium carbonate, mass divided by molar mass. Do we have mass? No, we don't. We don't have mass. But do we have molar mass? We don't. So this is a special case. Usually exam, right, they will provide you the relative atomic mass, which is your molar mass. But in this case, they don't. I provide to you. I assume that maybe they forget because usually they will give you one. So I'll write it down here. Calcium punya relative atomic mass is your 40. Carbon is 12. Oxygen is 16. Okay, relative atomic mass. Okay. So right now we have our molar mass. We just don't have mass because we are finding the mass, right? So here, mass we don't know. But we know that number of mole of CaCO3 is here given. Okay, so we know our molar our number of moles, right? So now we're gonna do our molar mass. So given here, relative atomic mass, calcium is 40. Calcium is 40. And our carbon is 12. And then 16 times 3 here, right? Because why? Why is it times 3? It is because that I have CO3, right? Oxygen, CO3, O3. So 16 O is 16 times 3, 16 times 3. What you're gonna get? You're gonna get 48. You're gonna get 48. Meaning, right, 40 times 12 times 48, you are going to get 100, right? Next, letak copy and paste balik. Okay, 0.003, and then you bring it up. Normal mathematics, very simple. I'm gonna move through 2 times 1, 2. So you are gonna get your mass as your 0.3 gram. Question done. Yay. So thank you guys for watching, and I'll continue my next video. Bye bye.